Hey guys, welcome to my second video in my series of stats tutorials. In this one we will be going over types of graphs and plots and a little bit of terms to know about these graphs and plots. So the first one, which I'm sure we're all familiar with, these are bar graphs. Now I don't think I need to tell you what they are, but I will show you a bar graph. So we have some parameters, sorry, I'm not trying to avoid using stats terms that have other meanings. So you have your different categories: blue, yellow, and green. Those just happen to be the primary colors. So what's your favorite primary color? We asked 30 kids what their favorite primary color was. And so 10 of them said blue was their favorite primary color. 9 said yellow was their favorite primary color, and 11 said green was their favorite primary color. And as you can see, this is almost it's pretty straight bar graph, showing a uniform distribution in people's favorite primary color. And so now it's not perfectly uniform, but as you can see, you can generally see that it is almost even across this bar graph, and we would call that a uniform bar graph. And so another type of bar graph you might see is a bell curved one. And so blue, yellow, green won't be good for, determining anything meaningful out of a bell curve. So let's do this with test scores. So kids that scored below 40. So below 40, then we have 40 to 60, and then above 60. And so maybe only a few kids scored above 40, and then most kids were between 40 and 60, and then we also had a few kids that were above 60 in their score. And as you can see, this follows a bell-like path or a parabola-like line, and then you can call these mound-shaped, bell-shaped, whatever you want. But it's important to know that, and it doesn't have to be perfect. Just remember, if that's the general look of it, that's what you call it. Okay, and then the last one is a skewed graph. So let's use the same group of the test scores, and like before, a few kids scored below 40, and then a few more scored between 40 and 60, and then some more scored, and the most scored above 60. And so as you can see, this gets increasingly larger, and like before, it doesn't have to be perfect. Like if there were another subset in between here and another one here, it doesn't perfectly follow a straight path, but generally more kids scored higher. So this is a skewed left graph because it is shorter on the left side, so we call it skewed left. Now let's use the same score distribution. Let's say the most kids scored below 40, a few less scored 40 to 60, and least scored below 60, and it follows a general downward path. This would be called skewed right because it is smaller on the right side of the bar graph. Okay. We'll return to bar graphs in a minute, but I want to go to stem plots or stem and leaf plots next. Stop it. Hey, one note. Okay. So stem plots, and also known as stem and leaf plots. And so this one you might be less familiar with, but I'm sure you've seen it around before. So basically you have a single number on one side, and then a bunch of numbers on the right side, and this side represents the tens place. Tens digit. These are going to be numbers, and that'll be the tens place. Then we have some numbers, along this side. A bunch of numbers. Blah blah blah. 5, 6, 7, 8, 9. You can do multiple repeats. And so what these numbers represent are a lot more numbers that are shown are in the actual data set, and that this is just a way of condensing down your data, because these represent a bunch of numbers. They represent 12, 13, 23, 24, 25, 34, 35, 36, 37, and so on. And if you're not catching the pattern here, then this is the ones place, and so this is 10. If you combine 1 and 2, that makes 12. 1 and 3, 1 and 2, 12. 1 and 3, 13. 2 and 3, 23. 2 and 4, 24. 2 and 5, 25, and so on. I'm hoping you're getting how to read these. And so these are very useful if you have a lot of numbers and you just need to condense them down some, and they're all, in the tens place, and can be easy. Like, the scores from 0 to 100 are easy to represent. If these are test scores, then it's easy to represent on this kind of stem plot. And so you can also, if you have two classes, let's say we're doing test scores again, and this test, we'll say this test was out of 60, so 6, and so you have class 1, you have class 2. Once again, just got some numbers over here. I don't know what numbers they are. Numbers. Actually, we're not gonna have anything over on this side for 6. 6 has nothing. There's nothing in 6 for class 2. And for class 2, you'd read it just like we did above. 1 to 1, 11. 1 to 2, 12. 1 to 3, 13. So class 1, slightly more difficult, just having to read it backwards. You've got 1, 1, 2, numbers. And one kid in class 1 got a 60. A perfect score on the test, good for him. And it's easy to represent two different groups of sets in a stem plot or stem and leaf plot. And so this is what you use a stem plot for, and there aren't really any terms I want to go over, but I will go back up here to our first plot. And if we think about this as a bar graph like we did before, you might see that we have kind of an increasing. If we were to turn this sideways, and I can't really do that, but if we were to turn this sideways into a bar graph, it would be increasing. I'll draw that out visually for you. So we have kids in the 10s, 20s, 30s, 40s, and 50s. And so we had 2 kids in the 10s, 3 in the 20s, 4 in the 30s, 5 in the 40s, and we also had 5 in the 50s. And so as you can see, that's generally increasing. And so this would be a skewed left graph, and you can see that in the stem plot just a little bit. If my writing was more neat, it'd be easier to see, but I'm kind of scattered all over the place. But you can also use a stem and leaf plot to see what you had earlier seen in a bar graph. Sometimes, not always. And for something like test scores, you can do it just like you would in a bar graph. It's increasing. Okay, and a less important type of plot is a dot plot. It's a dot plot, and it's a little bit self-explanatory. It's not very important, but you just have a line here. And we'll use test scores just like we have. And so 10, 15, 20. This test was out of 20. There's 15. There's 20. Here's 10, 11, 12, 13, 14, 15, 18, 19, and 20. And so a dot, you just put a dot over. If a kid got a 10, you put a dot there. If a kid got 11, a dot here. If 2 kids got 11, you put a dot there. And so forth. And yeah, easy test. Most students got a 20 on this. You can see there were 8-ish kids that got a 20 out of 20 on this quiz, and represent that through a dot plot. And that's what that would look like. And like a bar graph, you can analyze something. This doesn't have much of a correlation. It was pretty random on my part, but you could use it just like a bar graph. So if I would make more dots, I'm not trying to be neat, then blah blah blah. We have another skewed left graph as it generally increases. So a dot plot, you can read it just like a bar graph, or just trying to get a general shape of the graph. Okay, and the very last thing I'm going to go over in this video is bar graphs versus histograms. And so I hope I don't confuse you by saying this, but whenever I was saying bar graph earlier, I was actually meaning to say histogram. A histogram is still a bar graph to someone who has never had stats. But we have stats. We know better. We know what a histogram is. So histogram is used for quantitative data. So if we're representing numbers, again, 10, 20, 30, and 3 students got 10, 5, I'm getting ahead of myself. Okay, so this goes from 0 to 30, and so a good histogram would look something like this. They're all connected and whatnot. And so the 10, this ranges from anywhere from 0 to 15, right in the middle of 10 and 20. And so any student that got between 0 and 15 would be in this first category. And let's say that's 3, this is 4, this is 5 students. And so if you range from 0 to 15, you're in this first bar. 3 students got between 0 and 15. And the next thing we look at is to be between 15 and 25, because between 10 and 20 is 15, and between 20 and 30 is 25. So, 4 students got between a 15 and 25 on this quiz. And 30, since it doesn't go above 30, but let's just say it did to keep consistent. The test didn't go to 40, but just to show you, it ranged from 25 to 30 if we didn't have this extra score. But if we did have this extra score, it ranged from 25 to 35. And I'm not trying to confuse you. Let's just take the 40 out. So if you got between 25 and 30, then 5 students got between 25 and 30 based off this histogram. Now, in stats terms, whenever we say bar graph, we use it to represent qualitative data. So if we go back to your favorite primary color, blue, green, yellow, it's just 3, 4, and 5 again. Then 3 kids, your favorite color was blue. 4 kids, favorite primary color was green. And for yellow, you had 5 kids whose favorite color was yellow. And there's no in between, green and yellow. Wow, I've been saying primary color, and green is not a primary color. Let's just ignore everything I say. No. Sorry, this is for stats, not for art class. So blue, green, and yellow. And so, we don't do in between. We're not like, oh, well, some kids, their favorite color was anywhere from between blue, green, and yellow, green. That's not how. Bar graphs are for qualitative data. Histograms are for quantitative data. Okay. I hope this video didn't drag on too long, and I hope you come to the next one. Hopefully it'll be more interesting. I'm just trying to get the overview all done. And I know I've been sniffing a lot. I'm a little bit sick. The next video I make, I won't sound like this. I'll be better the next time I make a video. Alright, but thanks for watching, and I look forward to seeing you in the next one.